Hi all. So in this video we are going to learn about how we can insert a new node at the beginning of a doubly linked list and as well as at the end of a doubly linked list. So okay, this node has gone very big. So you can understand why this has gone big because we are going to store now two addresses. So in a doubly linked list node, we have the address of the previous node as well as we have the address of the next node. Hence, definitely the node size has to be bigger to accommodate two pointers. Okay, so let's say we have this data here in the data field. In the previous field, we have here null since it is pointing to no node, and then we have the address of the next node. Here it points to the previous node, and here it has the address of the next node, that is 300. Then it is 200, that is the address of this node. Let's have this addresses as well. Okay, and this is the last node. So we have this null pointer here. Again, we have this head pointer pointing to this first node. Okay, let's say we have to insert a new node at the beginning. Okay, so first we will see void insert at beginning. Okay, this is our function. Here we are going to provide the dnode pointer head, of course, because you remember dnode, we have created one structure. Okay, so struct dnode, and then we have the pointer as previous and next. Okay, so we have defined the type def struct dll node as dnode. Okay, you can have this as a node as well, it won't matter, but just for simplicity we have just named it as dnode. Okay, so let's say we have to insert a new node here. So what are the things that we are going to do? Definitely we don't need to traverse all way down here. Only we need to create a new node. Let's say we have this dnode pointer temp. Temp will be our new node. So we are going to allocate the memory space to this. So temp dnode pointer, and then we have this malloc function, and size of dnode, of course, size of dnode, and we have now created this node, and then we are going to supply data to this temp data equal to data. uh, okay, let's take the data from the user only. So and let's say printf, and we are asking data, enter data. So we need to enter the data from the user right here. Then we have the scanf, and in the scanf we are going to supply percentage d and address of temp data. We are taking the data at the temp. Okay, and now we have that data in the temp of next. We are having null. Initially we need to supply null to this, and then we'll see how we can update. And in the previous also we are having null. Now let's say for this linked list, let's say we don't have these three node. Okay, let's say we have only one node here. So we will check that, or if we have no node, f head equal to null, then definitely this is our first node. Then we can have this as head equal to temp. Of course, we don't need to do anything here because we already have updated this. Now let's say if we have this two node or one node already there in the linked list. So in the one node, we are going to, in the first node, is address is being contained in the head. So obviously we have to move the head to our temp. So before moving that, we need to have the temp next pointing to head. temp previous is obviously set to null, and head is going to point to temp now. Okay, so this way, and temp previous, temp next is head, and of course we need to update this link as well, very important. This part, let's say this part, if we have inserted a new node here, then it will be null. Here it will be containing the address contained in head, but there should be one link extra need to be maintained, that is in the before making this head point to this, we need to have the previous of head point to this temp. Okay, this is very important. So just a second. So of course, before making this, we need to have the, let's delete this first. Okay, and here in the previous of head, like head is originally now pointing to 100, so in the previous of head we need to have the temp. Okay, and then we need to point the head to temp, right, this way. So there will be two pointer updation for insertion. Okay, so this is the pointer update for inserting a node at the beginning of the linked list. Okay, so here we have inserted a new node at the very beginning of the linked list. Right now, if we have to insert a node, let's say here at position 2. Okay, so definitely we need to go to this position 2. Right now, what we have to do? We have reached the position equal to 2. Now we have to insert a new node. Okay, so if we created a new node, so definitely this node has to be at position 2. Okay, so this node would be pointing to this node, right, and its previous has to point to this node. Okay, so again here there should be a pointer update, right. What could be the pointer update here? So definitely its previous should be pointing to this part, that is the 100. So you have to update that the previous of this has to be placed into this. Okay, and this address, that is the 200, has to be picked up from here. Okay, so this should be pointing to this. Now this 200 address will be contained in from this node, right. So obviously we need one pointer here also, so that we can have this 200, right. So this way we can just or don't need this pointer. Obviously we have this 100 address, so from the next of this part we can put this. So there will be some logic need to be update for the pointer, so that we'll see. First let's see how we can insert. If we want to insert a new node at the end of the linked list and end of a doubly linked list, how we can do this, right. We have to insert a new node here. Definitely we need to traverse up to the last of the linked list. Okay, so let's see, void insert at the end, void insert at end. Here we are going to provide the node pointer head. Okay, and we need to have the node pointer temp, and one additional pointer we need for a traversal, let's say pointer q. For the temp we need the data, so we are having the data as the node pointer. Then we have mloc function, and here we are having the size of the dnode. Okay, now we have this temporary data, I mean the memory allocation done. Then we need the data here. Before that, we need to update the pointers of the temp previous set to null, and temp next is also set to null. We are going to ask the user for the data, that is printf enter data. We are going to have the data here. Then scanf, and then we have percentage %d, an address of temp data. We are going to have the data from the user. Then now we are going to check that if we have no node in the linked list, that is if head equal to null, then what we are going to do, we are making the head as sorry, this is already there, head as temp. That's all we need to do, and we need to come out of this. Else, that is, we have already some nodes in the linked list, so we need to traverse. So we are supplying the head to queue, and while next of queue not equal to null, we are going to traverse. We are going to update the queue as queue equal to next of queue, of course. When we reach the queue, so that the queue next becomes equal to the null, that is, we are at the last node. So if we are at the last node, like here, you see, we are at the last node. So here we need to update this next of queue as temp, and the previous of temp as queue. Okay, next of queue, next of queue as temp, and the sorry and the previous of temp as queue, and the next of temp is obviously null. We don't have to do anything, and we'll come out of that. We'll make update the two pointers as null, so that there shouldn't be an unnecessary pointers, dummy pointers here. So this way we can insert a new node at the end of the linked list. We need to update the two pointers here. Okay, we'll see about the deletion as well in the next lecture. So till that, goodbye. Keep watching the video, and please do like and share, subscribe if you're liking my video or the channel. So thank you very much.